In this video, I'm going to teach you about the concept of the limiting reactant in a chemical reaction. So the basic idea here is, when you run a chemical reaction, here's a reaction between some red stuff and some yellow stuff, and that's going to create this orange stuff. In your mind, you kind of assume that both the red and the yellow are both going to get totally used up, and that's going to create the orange stuff, and when the reaction is over, all the red will be gone and all of the yellow will be gone, just like it shows in this animation. Well, that isn't actually reality. In reality, you don't know if only one of them is going to get used up or both are going to get used up, and it's really hard to tell from looking which one is going to go first. So here's a more realistic example where I'm running the reaction, and you can see that the red stuff gets used up faster than the yellow stuff. We still create the orange product, but at the end of the reaction, there's some yellow stuff left over. Okay, so that's one big point to point out with this limiting reactant concept, is that when you run a chemical reaction in real life, you don't use up both reactants. There's always something left over, and so when you finally finish the reaction in your beaker, you have a beaker full of product plus the leftover excess reactant. So in this picture, the yellow is called, right here, this is called the excess reactant. Excess means extra. And the red is the limiting reactant. It's called the limiting reactant because the red one limits the reaction from going any further. You'll see that as soon as the red is gone, the reaction stops and it can't continue. And that's the way it works in real life. Here's another picture. Notice we're starting with the same amount of red as yellow. But just because you start with what looks like the same amount doesn't mean that you can predict exactly what's going to happen. Here's another example. Here we're starting out with a lot more red, so it would look at first like red is going to be the excess and yellow is going to be the limiting. Because there's less yellow, you would think that yellow would run out first. But again, in real life, the two reactants don't get used up at the same speed, and you can't predict that without doing a calculation. So here's the concept. In a video, I'm going to show you how to do the calculation and figure out ahead of time, before you run the reaction, which one is going to run out first. So let's go ahead and take a look at that calculation. I'll go ahead and throw this definition into your notes for you. So the limiting reactant is the one that runs out first. And you can expect to see this on a quiz, this definition. The opposite of the limiting reactant, again, is called the excess. And that's spelled E-X-C-E-S-S, excess reactant. And you have more than enough of the excess reactant, right? You could almost say you have too much. I'm going to put that in quotes because it's not like you need to use less. It's just the one that you have more of. So an example. Let's just take a simple single replacement reaction. Let's say you put some magnesium metal into a beaker, and in that beaker you have dissolved some aluminum chloride. Aqueous, it's dissolved. And in a single replacement, the metals switch places, so you'll be left with aluminum solid plus magnesium chloride. And now the magnesium chloride is going to be dissolved. And then we go ahead and balance this equation. So the chlorine is the one I'm going to do first. You notice we have 3 on this side, but only 2 on this side. So I'm going to put a 2 there and a 3 there to pop these up to 6. Put a 3 in front of magnesium to balance that, and a 2 in front of aluminum to balance that. So here's our equation that we're going to run. And let's just say that you start out with 10 grams of magnesium and 10 grams of aluminum chloride. Which one is going to run out first? Now, some of you, if you've been paying attention, noticed in the video that the coefficient of the one that ran out faster was a 3. And I put that there to kind of tip you off that those coefficients have something to do with how fast it's going to run out. However, with grams, you can't assume that that number is going to tell you what you need to know, because remember that 3 is in moles. So we have 3 moles of magnesium plus 2 moles of aluminum chloride. But I'm telling you your amounts in grams, so you can't really predict that the magnesium is going to run out first. And here's how you actually do that calculation to make sure. What you do is you're going to do 2 stoich calculations. One of them is going to start from the aluminum chloride, and you're going to do that calculation over to a product. So you say, if I start with 10 grams of aluminum chloride, how much aluminum solid will this reaction make? Then you do a second calculation, and you say, if I start with magnesium, 10 grams of it, how much aluminum will be made in that case? And you just look at both scenarios, and then when you can compare, that will tell you which one is going to run out first. So I'm going to start with the magnesium. 10 grams magnesium. We have our parentheses here. This is our first conversion factor where we're converting from magnesium grams to moles. Then in the middle comes the mole to mole ratio. I need moles magnesium on the bottom, and I need moles of, I chose aluminum on top. The aluminum has a 2 in front, the magnesium has a 3 in front. And finally, I am going to convert from moles of aluminum to grams of aluminum. So 1 mole of aluminum, I believe, is 27.98 grams. Turns out I was wrong. It was 26.98 grams. Okay, and then I'm going to run a second calculation here, starting with the aluminum chloride. So 10 grams aluminum chloride. Do the conversion factor. I'm converting from grams of aluminum chloride over to moles of aluminum chloride. Here's my mole to mole ratio. Aluminum chloride has a 2 in front of it. I'll put that on the bottom. And again, just like my green arrows show, I'm trying to figure out how much aluminum solid will be produced in the end. So I'll go to aluminum again. And that means the back end of this is going to be exactly the same as the top calculation. So then I go ahead and I punch these into my calculator. First one is 10 divided by 24.31 times 2 divided by 3 times 26.98, and that one equals 7.39. I'm going to round that off to 2 decimals and just say 7.4 grams of aluminum. Then I will do the one on the bottom. We start with a 10. Going to divide by 133.33 times 2 divided by 2. That does nothing, so I'm going to skip that because multiplying by 2 and dividing by 2 are opposites, so that'll cancel. So I'm just going to multiply by 26.98 equals 2.0 grams. Okay, and then the final step is which of these two numbers is smaller? The bottom one is smaller. Okay, and that means that right here, aluminum chloride is the limiting reactant. Why do I choose the smaller one, you ask? Well, basically what I just did is I asked 2 questions. I said, if this reaction uses up all 10 grams of magnesium, then how much aluminum will I get? And then I asked, well, if this reaction uses up all 10 grams of aluminum chloride, then how much aluminum will I get? Well, just like we saw in the picture, as soon as the limiting is gone, the reaction stops. Okay, it's not going to keep going and use up all the excess reactant. If it used up the excess reactant, that would make even more of the orange stuff here, the product. Okay, the reaction stops after it makes 2 grams of aluminum. So that's how I know that aluminum chloride here is the limiting reactant, and that's why I chose the smaller one, because it's going to stop early. And that's pretty much it. The questions on the test are just going to ask you which reactant is limiting, and you just have to do these 2 calculations, and that's all there is to it. Now, one last thing is, I chose to calculate over to aluminum as a product. I could just as easily have done the exact same thing with magnesium chloride. It really doesn't matter which product you pick for these calculations, as long as both of the calculations go to the same product, so that you're comparing the same 2 grams of the same product at the end. I chose aluminum in this case because I knew it was going to be less work. If I chose magnesium chloride, I would have had to do more adding and multiplying here to figure out this molar mass. So I took the easy way and chose the aluminum. So this is all there is to it.